So yesterday we talked about the general form of an exponential. Some of you may need to have next to these ones somewhere on your study sheet, and I will probably help you out with that a little bit. When it's a word problem, so this is in general, right? In general, you have this. So you have either an increasing function or a decreasing function. That's general. But when we transition to word problems, folks, we most likely will not care about that because x is going to be time. So we're going to start somewhere on the y-axis and we're going to go towards the x-axis like this, never touching the x-axis. Okay? Never touching the x-axis. So that could be one scenario, or let me see if I can squeeze that in. That's a decreasing scenario. If you're increasing, you're starting, it could be money, population, you're going to go up like that. Okay? So it's either decay or it's growth. Okay? So that's something that you need to, we're transitioning from general to word problems. Okay? So word problems are usually just within the first quadrant. Okay? Listen carefully to this part. It makes it challenging to graph because we're not going to have an x-intercept. We don't know where to connect the dots to. So we are going to have to come up with some points using the calculator and no problem, right? So we'll find 1 or 2 points until we see that shape and then we graph, okay? We learned that A is the y-intercept, and we learned that B, if it's greater than 1, we have an increasing function. If B is less than, like between 0 and 1, it's going to be decreasing. Okay, that's another thing. So I would expect you, okay, in the future, in the near future, if you were to see this, and I'd ask you what's happening to the population in this case, I would want you to respond, it's decreasing, because B, you clearly identify this as B is less than 1, so it's between 0 and 1, and it is decreasing by 5% every year, right? 0.05. You turn that into a percentage, it's 5%. I would expect you to see this and be like, oh, this is greater than 1. So it's increasing, my population, money, you name it, it's increasing. By how much? By 5% in this case. So those things I would like you to know. I could also ask you just by looking at this, okay? Let's look at this one right here. I give you this equation. Forget about all the numbers. I just give you this and I ask you, we're talking money here. What was the initial investment in this situation? You should immediately know that it's this number. That's my starting point. That's my y-intercept, $6,500. What's happening to that investment? Is it growing or is it decreasing? You should be saying increasing because it's greater than 1. By how much? You take this, right? You go this minus 1, multiply that by 100, and you get your percent from that. So 2.5% annually. Okay, so let's go to page 8. I just want to talk a little bit about E. E is it's like pi. Okay, so E is not just a random letter from now on. E is Euler's number. Okay, you don't need to remember what it is. You just need to know that that's what we're talking about. So highlight that, please. E stands for Euler's number. It is used, it's an important constant. It's an important constant that is found in many contexts and the base for natural logarithms as well. It is an irrational number. E, Euler's number, is 2.71828 and so forth. It never ends. It's similar to pi for that reason. Euler's number is used in everything from explaining exponential growth to radioactive decay. In finance, Euler's number is used to calculate how wealth can grow. But don't confuse Euler's number with Euler's constant. Uh-oh, what's that? You don't have to worry about this because here it is. If you ever want to know what it is in your calculator, you grab your calculator and do you see, if you look at your division symbol, do you see E right there? You see a lowercase e there. How do you access it? You go second, divide, and E will appear. If you hit enter, it will tell you what it is numerically. Not all the decimals, but the first, 8 or 9? 9 decimals. So if you don't need to remember this, to be honest. You just need to know E is, please use it as required, right? Better yet, look up here real quick. You see e to the x right here? E to the x. That's the one we're going to use most often. So second ln, it will immediately allow you to put an exponent up to e. So we are normally going to feed it x there, okay? And so it's basically, it's 2.71, never ending, to the power of x, okay? So it's an exponential function as well. All right. I'm going to skip this blank part right here. We're going to fill that in a little later. Let's go to page 9. You ready? Mentally, you got to be present right now, so try to put away any distractions. The population of a certain species of bees is modeled by the equation Pt is equal to 1500 times 1.15 to the power of t, where P is the number of bees and T is the number in the time in years. I need you to be good at this, okay? So this is your Y always, and this is your X right there. Always. Whatever's to the left of the equal sign is the Y, whatever is here is the X. So in this case, X is time. And this is the population, okay? I need you to understand that. T is my X variable, so I put that in the X, and therefore population is my Y. Every single time in this curve, every point you find is going to represent the time and how much you have, how many bees. What is the initial population? Explain. Okay? The initial amount is given to me by the y-intercept. And the y-intercept is 0, 1500 here. This is the value of A, okay? And I will let my audience know that this is A right here, and this is B, AB. So initial population is 1500 bees. Okay, so at the beginning we have 1500 bees in this scenario. Is the population increasing or is it decreasing? Explain. Since B is equal to 1.15, the population is increasing. Increasing, sorry. Okay, if B is greater than 1, we have an increasing function. So you try to the best of your abilities to convey something, right, to make sure everybody understands your point. what is the rate of increase or decrease? We already determined that it's an increasing situation. We want to state it as a percentage. 1.15 minus 1 is 0.15. 0.15 times 100 is 15%. %, per what? What is our time measured in? Time is in years. So when you find this, it is per year. And this is why. I'm going to go all the way up here to this part and make an arrow to that part. How long will it take for the bee population to double? Before I answer this question, let's graph this thing on our calculator. We should have done that right away, to be honest, but there was a lot of things we could do without it. So grab your calculator and let's type that in. Okay. I'm going to go to y equals, clear everything, 1500, bracket 1.15, close the bracket, make sure you do the exponent, and then x. Okay. And let's graph it. Let's see. Not a very good graph, right? What do I know? What's my y-intercept? 1500, right? You're listening to this part? 1500. So window, what do you think my y max should be? 1500, you're just going to see it crossing, right? We know it keeps going up from there. So I'm going to go 10,000. Does that make sense? Could I go 5,000? Yes. So it's up to you. You can kind of troubleshoot a little bit. I'm going to try to go y max 5,000. That's a pretty good graph. Do I care about this portion right now within this context? I don't. Because time here is negative, because remember the x-axis is your time. I'm just going to check, is my x min is negative and my y min is negative? That is always important. Okay, so this is a pretty good graph. We can work with that. Now let's go back to this question here. How long will it take for the bee population to double? Doubling, right? We start with, how much do we have to start? 1,500 bees, right? So double would be 2 times 1,500. We're at 3,000 bees. Okay. So what is the 3,000 for us? Is it the x or the y? I said it right at the beginning there. Time and then population, right? So it's asking what is the time when we have 3,000 bees? How did I come up with the 3,000? I doubled what I had initially. Okay. So this is how I'm going to show my work. Y2 is 2 times 1,500, which is 3,000. I'm going to let Y2 equal to 3,000. And then I will go ahead and find the time. So let's go to Y equals. I'm just going to say, I need you to understand, doubling time is a thing. It's a very popular thing when we're talking exponential or logarithmic. So do you see 1,500 there? You should immediately, if you're trying to find a doubling time, you'll just double that and put it in here. So 3,000, right? You should see that. Okay. if I start with 1, this should be 2, right? So let's graph this. So I'm interested in that intersection. That's going to give me the time that it takes to double my population, right? We're going double the population. So second trace 5. Go closer to it, hit enter 3 times. There it is, 4.96. 4.96. Do you remember doubling time? Where else did we talk about doubling time? Finance. You remember rule of 72? We were doing the same thing, but there we use a trick because we have the interest rate, and so we can do that. But this is exact. This is finding out the exact amount of time it takes. And I need to make a note here. I'm going to use a red pen, okay? Population doubles every 4.96 years. That's what you just found here. Once you find it, it stays the same. It's kind of like using the rule of 72. Once you find your doubling time, that time stays fixed, okay? So every 5 years approximately, the population of your bee population will double what you had previously. So if another 5 years go by, you will be at 6,000. Another 5 years go by, you're going to be at 12,000, 24,000, 48,000. So you're doubling every 5 years, okay? How long will it take to reach a population of 9,250 bees? So it's basically saying how long until you have 9,250 bees. We got to go y2 is equal to 9,250. Intersect. Now we're going to let y2 equal to 9,250. I don't see anything. How come? My window. Yeah. Let's go y max 10,000 or 15,000. I'm going to go 15,000. Okay, so now what? X max, yeah. Window. I'm going to go 50. Boom. So I had to increase X max, I had to increase Y max. Please know that that is a very common thing you're going to have to do. I just hit enter 3 times. There I am. X is 13.02 years. So it takes about 13 years to get to that population. How many bees after 60 months? What's that nonsense? You got to turn it to years. How many years would that be? You go 60 divided by 12, 5 years, okay? So how many bees in 5 years? So it's basically saying when time is 5, what will be the bee population? Second, trace, value, X is equal to 5. Second trace, value, 5. 3,017. That was basically my doubling time, right? 5. So I'm just over 3,000 in this case. What do you do when you answer that? Can you answer that in this case? Can you have that many bees? You can't. So you have to say approximately 3,017 bees. It's discrete. You remember discrete data versus continuous data? So if the question kind of begs for whole numbers, you have to give me whole numbers. Like on the test, tickets, you can't go 0.34 tickets, right? Or 0.33 tickets. You have to round it to a whole number. Watch this. If the maximum capacity for a beehive is 15,000 bees, determine the domain and range. What does that mean? It's basically saying this, folks, okay? Let's make a sketch. I love sketches for my domain and range. It makes it easier. We know it starts here, and then it grows, okay? So there is a start to it, and right now we put a stop to it as well. It says that basically what it's saying, after 15,000, bees are going to start dying, right? Like it just can't support it anymore, like it stops growing. So we need to figure out this point right here. Guess how we're going to do that? We can draw a line at 15,000, and then we'll figure out what the x value is at that point. So let's do that. Y2 is 15,000. I'm not going to, I do see it. I'm going to sneeze. False alarm. Second trace 5. This is borderline. Like sometimes the calculator acts up when you do that. So you might have to increase your Y max a little bit. So here we have it, 16.48. 16.48. So watch this. For my domain, I go from 0 to 16.48 years. Got it? For my range, how about we extend the range on the side here? Range, we go from 1,500 to a maximum of 15,000. This is my range. Sketches are really good for domain and range, in my opinion. So let's state it. Domain 0, 16.48. So we're talking about the years, right? For the range, 1,500 is the smallest, 15,000 is the largest. There you have your domain and range for this scenario. Question. Let's do this on the side here. What if you had, what if this didn't put a stop to it? Like, then technically, that's what we would have, right? This would be 0, 1,500. So my domain here would be 0 to infinity, and my range would be 1,500 to infinity. No stop, right? I like to have that right next to it just to understand that not always will there be a stop, okay? For money, if you let money sit in the bank account even after you pass away, it will just keep growing and keep growing, right? Like it just will never stop growing. So it is possible to have that. Let's go to page 10. Let's do a graph, and then I'll let you practice these questions, okay? We're good? I'm just making sure everybody got down the notes. And you know, I have to say this, your graphs for the most part, when it comes to those little things, like the labeling, the scale, all of that, way to go, guys. Way to go. I don't have much to say there. So please, at least that part, don't miss it. So this is time in years. You can honestly score a mark just by labeling. This is population. I will just make sure I don't get docked, and I'll say number of bees. How should I do this? I should probably fit in the 15,000, correct? So let's see here, 5, 10, 15, 20, no problem. And technically you start at 0, right? Same with time. How far do I need to go out with time? According to my domain, I need to make sure I have enough to get all the way to 16.48. So I'll put my initial point. This is 1,000 here, so this is 1,500 right there. Now I'll go to 16.48, which is right about there. And I'll match it with 15,000. I would like one more point, at the very least. Do we have a point we can borrow from our previous work at all? I see 5, yeah, 5, 3,000, right? Right about there. Can I borrow another one? Wasn't it question E? At 13 years, I'm at 9,250. Hey, you go get these points if you need to. And let's connect the dots. You thought they would never come back, right? We were training you in kindergarten and grade 1. Connect the dots, connect the dots. For this moment. And if you, when you did inequalities, the shading part, right? Stay within the lines. We're training you for that too. So this is it. I'll make a note. Use calculator to find points, right? So if you need to find more points, just go second trace value and plug in any x value that you'd like to give you something in between. Okay, I'm going to stop here, and I want you to try. I'm going to ask you to try 12. Page 12 to 14 for now, okay? Just so you know, you will come across an example where this thing is going down. So I will let you kind of struggle with it a little bit before I give you an example, okay? So please work through this. I will give you the key. I will post the key, and then you can work through that, okay?